the next thing that we're going to talk about is the forward address, and this is where things become rather complicated. Now, they become complicated because the forward address is something that goes very, very deep in behavior OSPF, but is also something that makes this behavior possible. It allows R4 in this scenario here that based on only 5,000 LSAs generated by R3 can have 10,000 routes that take some traffic this way and some traffic this way. So let's take a look at how forward address behaves. Now, there are two important things about the forward address, and one is the behavior of the forward address when we have the NSSA and when we have non-NSSA area. Now, when we have NSSA area, the rule of forward address is very simple. There will always be a forward address, so it will always be inserted into type 7 LSAs. Now, what I mean by that, when we have a router here, let's say that, for example, it's R1, and let's say that this is indeed NSSA area, and this router here had some external routes that were being redistributed into OSPF. When this router R1 redistributes these routes, so it is an NSSA ASBR, this router will always insert a forward address. Now, the value of forward address when we are dealing with the NSSA area will always be one of, so it will be one of ASBR's interfaces. And this interface must be enabled for OSPF. And preference is given to loopbacks. So when this router here injects these routes into the OSPF, when it generates type 7 LSAs, the forwarding address will be one of R1's interfaces. Now, let's see how that works in our previous example. So in this previous example that we used here, so I'm just quickly going to make a copy of this page. So the this router here, that was an NSSA ASBR. So this is an NSSA ASBR. This router here actually injected the forward address of R1. So this here is actually an IP address. So this is not a router ID that is inserted. So this is an actual IP address. So when this information arrived to R2 and R3, at this point decision was made because of the higher router ID that it will be R3 that actually translates this into type 5 LSA. This forward address information is actually going to be injected into these LSAs as well. So on these 5,000 LSAs here, I'm going to have the information that the forwarding address here is one of the IP addresses on R1. But because of the requirement that this address is actually enabled for OSPF, so there is that rule here. It says always inserted into type 7 LSA. It's going to be one of the ASBR's interfaces, and it must be enabled for OSPF. So this is the significant part. Because this was enabled for OSPF, the assumption is that this will actually be available outside the area. So here, R4 now has these 5,000 LSAs, and it knows they are coming from an IP address of R1. So what this router here is going to do, it's going to see what is the best path to reach this device. What is the best path to reach this R1? So let's say that R4 here has two equal costs. One is using this interface here, and the other one is using this interface here. So if I have two paths to reach the forward address, that means that I have two paths to reach these 5,000 LSA. So this is the reason why I can have 10,000 routes in my routing table just based on the information that originally came from a single ABR, and why we don't have to have this duplicate information. So this is what the forward address does. It allows for certain shortcut in routing. So I'm just going to put this in here. So it allows us to have a shortcut path calculation, let's call it that way. So when you have an NSSA area, the rule is very simple. It will always be inserted, and it will be one of the ASBR's interfaces, and this interface must be enabled for OSPF. Now, when we are dealing with the non-NSSA area, the situation is slightly different. So let's take a look at that example. So again, I'm going to have R1, and to understand why we might need this, I need to have slightly different scenario. So let's use the same network. So this is going to be R2, R3, and R4. Again, this here is going to be area 1, 2, 3, but now this is not an NSSA area, and let's say that this here is area 0. But this time, not all links are of equal cost. So let's say that this link here is slightly higher bandwidth, so that this interface here is, let's say, 10 gigs, and that this interface here is 100 megs. Now, let's say, for example, that actually this is relatively bad example. Let me think about. Apologies. I'm just going to use slightly different example. So let's say that here I do have R1, and let's say that I have R2 and R3. I knew there was a reason that I wanted to have a different example here. And let's say that here I have my R4. Now, again, let's say that this is the division here, or it doesn't even have to be a different area. So this is not necessarily tied to multi-area operations. So let's keep this just all in a single area. So let's say that this is area 0. But this link here, as I was saying, let's say that this link here is slightly more bandwidth. So this link here on R2 to this shared segment, let's say that this is a 10 gig interface, let's say that this is 100 megs, let's say that this is 100 megs, and let's say that this is 100 megs. And let's say that R1's link here is actually same 10 gigs. So this here is a 10 gig path. So this is 10 gigs here. Now, let's say, for example, for whatever reason, and I'm not necessarily saying that this is the right thing to do, but let's say that indeed this is the case that we have. Let's say that R3 here had a static route for some network N that sits behind. So our OSPF actually ends here. So let's say that R1 here is not running OSPF. So area 0 is here, and here we are not running OSPF. So there is no OSPF in this part of the network. And let's say that we had on R3 a static route for N that uses this as the next hop. So this interface here is the next hop. And let's say that on R3 we actually have configuration that actually takes this static route and redistributes it into OSPF. So when we arrive to R4, here we are going to have information that network N is reachable through R3. Now, the amount of traffic that we can send there, and let's make it even more fun. So I'm going to actually change something here. So let's say that this is a 10 gig interface as well. So this is a 10 gig interface here. So when this information reaches R4, R4 only has this information here to go on. It knows that this is coming from R3. If this is coming from R3, that means that we can only use 100 megs to send down this path. So this 10 gig path here is going to become unused. Now, you might be thinking, why am I not redistributing from R2? But as I said, this is besides the point. For whatever reason, if you have this situation, this is what you're going to end up with. And this is what forward address can actually help us solve. If certain conditions are met, so here I'm just going to say, going to use red here. If conditions are met, forward address will be the next hop of external route. But important thing to note there is that the conditions need to be met. What are those conditions? Well, the conditions are exit interface for external route must be enabled for OSPF and must not be passive and must be broadcast or non-broadcast. So if these conditions are met, the forward address, so these are, let me put this in. These are the conditions. So if these conditions are met, the forward address will actually be installed. Now, let me explain why these conditions exist. So at this point, we know that this interface here must be enabled for, or actually not that interface, but that this interface here must be enabled for OSPF, that it must be non-passive, and that it must be broadcast. Now, if we assume that this interface here is also enabled for OSPF, even though it's irrelevant whether we actually do have the neighborship here or no, but let's assume that this interface here is actually enabled for OSPF. If we receive here information that the forwarding address is this NH that I used here, what R4 can do is see, okay, what is my best path to actually reach the NH? And if we take a look, what is the best path to reach this NH? It will, of course, be this path here. So we can actually send the traffic down the high bandwidth link instead of using the low bandwidth link that we have on the other side, even though the actual route, the actual LSA came from the router that is using a low bandwidth link here, because the cost to use this link is lower. But in order for this to work, all those conditions must be met. So this is what the forwarding address can do for us. It can allow this shortcut in routing. It allows us to bypass the lower bandwidth paths in preference to higher bandwidth paths, or lower cost paths in comparison to higher cost paths. But all these conditions must be met. And there is one more crucial condition. In order for OSPF forward address to actually be used, so for forward address, and this is extremely important, for forward address to be considered valid, it must be known as OSPF route. Now, what that means in plain English, if on the local router the forwarding address is not known as OSPF route, the LSA that contains it cannot be used for routing. So if forward address is known from other source in the routing table, type 5 or type 7 LSA that references cannot be used. This is extremely important, because if we have this situation that the forward address is known from an external source, what's going to happen is that if the forward address is known from any other source in the routing table, that means if you have a forward address that is known by a static route or from EIGRP or from RIP or any other routing source, that will cause the OSPF to consider the LSA that is actually referencing this forward address from this other source to be considered invalid. That LSA type 5 or type 7 cannot be used in a routing table. You will see it in the database, it will be flooded to other routers, but it will not be used in the routing table. So everything will appear to be right. There is nothing wrong with that LSA. It's just that OSPF cannot trust the information from that LSA. If you take a look at it, it is going to think that it cannot guarantee that this LSA is loop-free. Why? Because it has forward address that is outside of its domain. If the forward address was from OSPF, if it was known by OSPF, OSPF would know it's loop-free because OSPF is loop-free. But if you are referencing an external information, the OSPF goes like, oh, wait a second here. This is not something that I can use because I cannot guarantee that I'm not going to create a loop if I use this information. This is why it's very, very important that you pay close attention to this, that you keep this in mind, because this is something that they can or will put in the troubleshooting labs, for example, to trip you up. Because this is such a deep understanding of how OSPF behaves, especially when dealing with non-NSSA areas. I mean, just take a look at these rules. Unless you are a CCIE instructor who does this pretty much every day, who can possibly remember these? So keep this in mind and just remember that forward address must be known from OSPF to be considered valid. If you know it from any other source, OSPF cannot actually use this information for routing.